Okay, so this is question number 10 from 8.1 Pre-Calculus 20. We're talking about vertical curves. Now that may look a little bit funny, but in the textbook there, I believe in one of the examples that we might not have gone through in the lesson, it talked about how you would connect two straight lines like this if you were trying to build a road, or in this case a roller coaster. So you'd want this roller coaster that's coming down this straight part of the track. You don't want it to hit a big corner here and then bump, bump, right, and then go here. What you want to do is you want to try and build some kind of bridge in between, right, so that the roller coaster can come down here and then nicely go along this bridge and then just melt into the next grade. So that's kind of what they're talking about. And here's the here's a roller coaster here. It might kind of look like just a series of parabolas, right? But there are stretches where the roller coaster does go straight and then it curves to another straight part, let's say. And so what we're interested in is the connection between these two straight parts and how we're going to connect that with what would be a parabola here. Okay? So that's what this is talking about. So really quickly, I'll go back to my two straight lines here. If I can just erase the red. Oh, couldn't do it. But you're given two lines. It says this. One downward sloping grade line or section is modeled by this line right here. Excuse me. So we have y equals negative 0.04x plus 3.9 for that slope. Okay. And then another one is this one here. We'll do that in red over here. That's positive 0.03x plus 2.675. Okay, so that's this next line. The vertical curve between the two lines is modeled by this equation. So they give you the equation of the parabola, which would kind of like be something like, this, let's say. Okay, so you would have two connection points here and here between those two lines. These black lines right here right now are called tangent lines. Right? And so again, the roller coaster comes down this part of the track and then it picks up this parabola and it's a nice smooth curve to get to the other part of the track. That's what we're calculating. And so it says determine the coordinates of the beginning and the end of the curve. So the curve part is from here to here, right? That's the curve. Apologies. So you're basically just looking for intersection points between the one line and the parabola, and then the second line and the parabola. So what we'll do is we'll get our graphing calculator out here, and we'll plot the two lines and the parabola all at the same time, and we'll just find the intersection points. Okay? So let's put those into our calculator. So you want to get all three equations into the two lines and the parabola. Please remember that if we have a negative, so that's at the beginning of the expression there, it's this negative button, and this is a minus, okay, right here. Okay, so I don't know how my graph will look, so I'll just go standard graph there. Oh, this looks like that's not a good picture of this, is it? So let's just go back and quickly examine our lines. This is a very slight slope, right? It's very close to a zero slope. It's almost a horizontal line. So the two slopes are very, very slight. This parabola is also very, very flat. Like it's a very wide parabola because A is so small. Okay, so we have to figure out which is the parabola, which is the line. I have to figure all this out. So let's zoom out. You can just zoom out. You can go zoom 3 and then just hit enter and it'll zoom out for you, and that might help you determine kind of what we're looking at here. Okay, so that's very tough to see, right? Very, very difficult to see, but it looks like we have two lines that are almost horizontal, and we also have a vertical, a parabola that's opening upward. So now let's zoom in and see if we can find one of the intersection points. Or what we could do is change the vertical axis window, so the y max and y min. I could change those so that they're pretty narrow, and maybe this might work. So let's make these numbers smaller on the y max and min. See if that helps. Let's just see what that shows us. Oh, That's a little bit better. And there's the parabola. Hey, look. So just adjusting the window, we can kind of see that, it looks like we have an intersection point here and an intersection point over there. You could change the window real quickly one more time if you want. The y min could maybe be 2. The y max could be just a little bit higher, and then I could also change the x part a little bit too. So it's up to you. It's up to you what you want to do. But I'm going to change that so I can zoom in just a bit. So the y min I'm going to make positive 2, and the max I'm going to make maybe 5. And the x minimum, I don't need the negative so much, so I'm just going to shrink that down a bit. And then let's see, we should have a pretty good picture of it now. So you adjust your window a couple times, and then there you go. So I'm going to have an intersection point here, and then you follow the process to find intersection. And of course on the test, because we're looking at reviewing for the test here already, on a question like this, you will have the graphing calculator. You're not going to have to graph this by hand or anything, so you'll be able to do all this. So calculate 5. So let's do this line, and then we'll do the parabola. So you just keep hitting the up or down arrow until you get the one you want. So I've got these two, and now I'm going to move the cursor over to where the intersection between those two are, where it's near. And then I'm going to ask the calculator to guess, and then it should give me the it's taken a while. So x is negative 2.16 times 10 to the negative 5. So that's almost 0, but you want to be as exact whatever the calculator gives you. So x equals 2.17 times 10 to the negative 5. That would be, looks like one answer. And then you do the same thing for the other intersection. So if we do the intersection on the other side, you have 34.9 or 35 you could round it to. Okay? So 2.17 times 10 to the negative 5. And I don't know what the units are here. We could look for that units. It doesn't really give us. And then 35 as well. So those would be your two answers there. This is this point x value right here, and here's this x value right here. So determine the coordinates of the beginning end of the curve. So these are the x values. So I guess you're going to want to also find the y values because it says the coordinates. So that would be 2.17 times 10 to the negative 5. And whatever the y value is there, and that's easy to do. I'll show you how to do that in the calculator. And then 35 comma the other one there. So here's 35 and 3.72. And for the other one, you could just go calculate a value and plug in your first number. So 2.1, it was 66 something. And then here's your exponent times 10 to the power of negative 5. So 3.89 or 3.9. 3.89, let's say. So those would be your answers for number 10. Could someone just check in the textbook there to see if that lines up with what the textbook has? So in the textbook you'll find that this number right here they just said was 0, which is fine. This is actually 0.0000217. So that's pretty much 0. You can be exact if the calculator gives you that. But sometimes it picks a point that's really, really close to 0 and just shows you that instead of 0 sometimes. So, okay. But other than that, that looks like those are the correct answers. Okay.